right, this one we're going to talk about solids. I'm sorry, the last couple kind of got a little bit longer, so I'm going to try to go a little bit faster with this. When we talk about solids are solids, number one, because the particles have less kinetic energy, and because, two, they're in a crystal structure. They have an orderly arrangement, whereas liquids and gases do not. So when we talk about melting point, it's very similar to your boiling point. It is the point at which that solid becomes a liquid. Things are in equilibrium when you have something right at the melting point or freezing point. Notice you can call it either because it's the same temperature. If you are right at 0 degrees Celsius, you're going to have water freezing and melting at the same time. So let's talk crystals. A crystal, what makes something a solid is it's going to have a crystal structure. Now, sometimes it's not very orderly, but we'll talk about that in a minute. But a lot of times it is. In a crystal, the particles are arranged in repeating units. That repeating pattern is called a lattice, a crystal lattice. And, well, I'm going to talk about that. When did I think in the fall, that's when I was taking the crystallography class, and we talked a little bit about that, so maybe you'll remember me mentioning some things about that. The shape of the crystal reflects the arrangement of the particles within the solid. So if you go back and look at this, the sodium and the chloride, they're side by side. You get a lot of, you don't have positives and negatives surrounding each other. You have to intersperse them to make things work, keep the attractions. But do you see how the arrangement of the particles reflect the actual crystal structure? And if you look at salt, you can see this nice crystal structure if you look closely, if you have like a microscope at home or something. The smallest group of particles within a crystal that retains the geometric shape of the crystal is known as the unit cell. So the smallest unit that you can get to be repeating over and over and over again, that is the unit cell. There are 14 kinds of unit cells. There are from 1 to 4 types of unit cells that can be associated with each crystal system. This goes well beyond what we need to be talking about, but at some point I think I do want to give a little bit more info on that sort of stuff because I enjoyed that class so much. So if you're interested, you can let me know, and maybe I can get you a little fun stuff to look at with that. So 3 kinds of unit cells can make up a cubic crystal system, so something that takes a cube shape. There's simple cubic, and that just has the 4 corners. But then you have the type that is body-centered and then face-centered. So you can have different particles interspersed throughout, and it definitely depends on the attractions and how things are going within the solid. Now, allotropes. This is a word you've probably heard before, and a lot of people, just forget what it means. They know that they've heard it, but they can't remember it. An allotrope is essentially just when you have 2 or more different forms of the same element. So, for instance, carbon, you can have graphite, you can have charcoal, you can have diamond, you can have, your carbon nanotubes, graphene, 1 sheet of carbon. They all have different properties because their structures are different. So the properties of solids depend a lot on their structure. They depend on what they're made of too, but that contributes to the structure as well. So it's all tied together. Only a few elements have allotropes. Here are some of the carbon allotropes. You can see a diamond actually kind of looks like a diamond. Graphite, those dotted lines are not real bonds. They're just kind of attractions. And so when you use graphite in your pencil to write, it will come off real easily. So it'll essentially just wipe onto the paper. And then you have your Buckminster fullerene. Now, non-crystalline solids. These are solids that don't have an orderly crystal structure. We call those amorphous solids. they do not have an ordered internal structure, and this would be stuff like rubber, plastic, asphalt, and glass. Glass does not have an ordered structure. A glass, so we have, our glass that we think of, but a glass is a transparent fusion product of inorganic substances that have become rigid. So we can make glasses out of different substances. It's kind of neat. All right, sublimation. You've heard of sublimation before. That is just where a solid converts directly into a gas, skips the liquid phase. This happens when the vapor pressure of the solid overcomes the atmospheric pressure. So it's the same thing as boiling. When the vapor pressure of the liquid overcomes the atmospheric pressure, that's when it boils. Well, when the vapor pressure of the solid overcomes the atmospheric pressure, it just goes straight to a gas. So some of the things that you probably can already think of that do this: dry ice, that's probably the big one, but you got mothballs, air freshener, freeze-dried foods, all that sort of stuff. Those will become gases directly. So here are just some examples, some iodine. All right, next we'll talk about phase diagrams, but that's for the next video.